The microprocessor. The microprocessor is an electronic circuit that acts as a central processing unit of a computer, providing control of the calculations. We could say that he is a computer's brain. Microprocessors are also used in other advanced computer systems, printers, cars, or aircraft. The microprocessor is a highly integrated circuit type. Integrated circuits, also known as microchips or chips, are made up of complex electronic circuits, formed extremely small components in a single thin flat piece of material known as a semiconductor. Modern microprocessors incorporate up to 10 million transistors, which act as electronic amplifiers, oscillators, or more often as switches, plus other components such as resistors, diodes, capacitors, and connections, all in an area about the size of a postage stamp. A microprocessor consists of several sections. The arithmetic logic unit, ALU, performs calculations with numbers and logical decisions. Records are areas of special memory to store information temporarily. The control unit decodes programs, buses carrying digital information through the chip and computer. Local memory is used for the computations performed on the same chip. The most complex chip often contain other sections, such as specialized sections of memory called cache and memory, which serve to accelerate access to external devices for data storage. Modern microprocessors operate a bus width of 64 bits. A bit is a binary digit, a unit of information that can be a 1 or 0. This means they can transmit 64 bits of data simultaneously. A crystal switch located on the computer provides a timing signal or clock signal to coordinate all activities of the microprocessor. The clock speed microprocessors is a more advanced August 00 MHz, about 8 to 00 million cycles per second, allowing you to run more than 2,000 million instructions per second. Computer memory. As a microprocessor is enabled by itself to accommodate the large amount of memory needed to store program instructions and data, text in a word processing program may be used. Transistors as memory elements in combination with microprocessors to provide the necessary memory. Integrated circuits using other chips called random access memory, RAM, which contains large numbers of transistors. Various types of random access memory. Static RAM retains information while power supply voltage and is often used as a cache and memory because it operates at high speed. Another type of memory, dynamic RAM, DRAM, is slower than SRAM and should receive regular electricity to not be deleted. DRAM is cheaper than SRAM and is used as a main memory in most computers. Transistors. The transistor most commonly in the microelectronics industry is called field effect transistors, metal oxide semiconductors, MOSFET. It contains two N-type regions called source and drain, with a P-type region between the two called channel. Above the channel is a thin layer of silicon dioxide, not conductive, on which is another layer called the gate. For electrons to flow from the source to the drain, it is necessary to apply a voltage to the gate. Voltage bias. This causes the door to act as a control switch, connecting and disconnecting the MOSFET and creating a logic gate transmitting ones and zeros through the microprocessor. Manufacture of microprocessors. The chips are manufactured using techniques similar to those used for other integrated circuits such as memory chips. Generally, microprocessors have a more complex structure than other chips, and their manufacture requires extremely precise techniques. The economic manufacturing of microprocessors requires mass production. On the surface of a silicon wafer, simultaneously create hundreds of groups of circuits. The chip manufacturing process consists of a succession of deposition and removal of fine layers of conductive materials, insulators, and semiconductors, until after hundreds of steps leads to a complex sandwich that contains all interconnected microprocessor circuits. For the electronic circuit, uses only one, the outer surface of a silicon wafer, a layer of about 10 microns thick, about 0.01 millimeters, 1/10 the thickness of a human hair. The steps include the creation process of substrate oxidation, lithography, etching, ion implantation, and deposition of layers. The first stage in the production of a microprocessor is the creation of a silicon substrate of great purity, a slice of silicon wafer as a round polish to be smooth as a mirror. In the oxidation step is a layer electrically non-conductor called dielectric. The most important type of dielectric is silicon dioxide, which grows by exposing the silicon wafer to an oxygen atmosphere in a furnace at approximately 1000 degrees Celsius. The oxygen combines with silicon to form a thin layer of thickness about 75 angstroms. An angstrom is 1/10 billionth of a meter. Almost all the layers are deposited on the wafer should match the shape and arrangement of transistors and other electronics. This is usually achieved through a process called photolithography. Almost all the layers are deposited on the wafer should match the shape and arrangement of transistors and other electronics. This is usually achieved through a process called photolithography, which amounts to turning the wafer into a piece of photographic film and project on it a picture of the desired circuit. This is deposited on the wafer surface a photosensitive layer whose properties change when exposed to light. Details of a circuit can have a size of only 0.25 microns. Since the shortest wavelength of visible light is about 0.5 microns, it is necessary to use low UV wavelength to resolve the smallest details. After designing the circuit on the photoresist and disclose it, the wafer is recorded, that is, removes the wafer not protecting by the recording image of the circuit by chemicals, a process known as wet etching, or by exposing a corrosive gas called plasma in a special vacuum chamber. In the next step of the process, ion implantation are introduced into silicon impurities such as boron or phosphorus to alter its conductivity. This is accomplished by ionizing the atoms of boron or phosphorus, removing 1 or 2 electrons and throwing them against the wafer at high energy ion implanter. The ions are embedded in the surface of the wafer. Future technologies. The microprocessor technology and manufacturing of integrated circuits is rapidly changing. At present, more complex microprocessors containing more than 50 million transistors and expected in the 2010 containing more than 800 million transistors. Lithography techniques also need to improve. Currently, the minimum size of circuit elements is less than 0.2 microns. With these dimensions, it is likely that even low UV wavelengths does not reach the required resolution. Other alternatives are the use of very narrow beams of electrons and ions, or replacing optical lithography that uses X-rays of extremely short wavelengths. Using these technologies, the clock speeds of 1000 MHz exceeds. It is believed that the limiting factor in the power of microprocessors will eventually be the behavior of their own electrons to circulate through the transistors. When the dimensions are very small, quantum effects due to the wave nature of electrons could dominate the behavior of transistors and circuits. It may take new devices and circuit designs as microprocessors are approaching atomic dimensions. To produce future generations of microchips will require techniques such as molecular beam epitaxy, in which semiconductors are deposited atom by atom in an ultra-high vacuum chamber, or microscopy scanning tunneling, which lets you view and even displays atoms in